finishing up multiplying by radicals, you're seeing the letters sneak into the problem now. Wouldn't be algebra class if I didn't throw an X in it, so here it is. It is the same skill. So we are going to distribute and we are going to FOIL, but as you know, when we go to simplify and there's variables in the radicand, that process does look a little different. So let's do it. We are going to go ahead and just distribute this square root of 3x in. Make that a little bigger for you. So this is going to look like the square root of 3x times 4 root 2x. Bring down your minus. And then we got the square root of 3x times the square root of 12. Now I am going to use my product rule here. This 4, it's going to come down there because I don't have anything to multiply it with. But the square root of 3x and the square root of 2x, I can multiply 3x times 2x. 3 times 2, that's just 6. X times x is x squared. Okay, we're going to hold that thought because we do have to simplify at the end. Over here, I can do, because those are both underneath the same radical, the square root of 3x times the square root of 12. 3x times 12 is just 36x. So now it looks like last night's homework, right? You need to just take some time to simplify both of those pieces. So that's what we're going to do. This will be 4 root 6 and square root x squared. So this square root x squared is just going to be x root 6. Bring down your minus, and then the square root of 36. And the square root of x is what we're thinking about, but the square root of 36, that's just 6. Now you could take out a GCF of 2, but there's no like radical to pull out there. So this is good in my book. I like it. Good job, guys. I will say, in general, I'm noticing a really good trend. Like, if you're working, like, one step ahead, don't get too far ahead. Periodically peek up. But if you're that kid who's, like, anticipating what I'm going to do next, these lessons go a little bit better. Plus, it keeps you more engaged. It's just, like, more interesting if you work ahead a little bit. So a lot of you are doing that. That's awesome. And then you kind of, like, stop and look. That's fantastic math learning habits. Good job. It is a little bit more interesting if you can get ahead of me. Now, if you're just like voraciously copying down, like trying to keep up, that means that this isn't going maybe the way we all want it to. So just feel free to throw your hand up. I'll come around. Okay, so yeah, FOIL problem. I have a binomial times a binomial. So I multiply my first together. We are almost done. We got the square root of 3x times the square root of 3. That's the square root of 9x. And then the square root of 9 is 3. Square root of x doesn't simplify, so that's 3 root x right there. Okay, outers. That's the square root of 3x times the square root of x. That's the square root of 3x squared. So this time around, the 3 has to stay underneath, but the square root of x squared is just x. Can't square root 3, though, so that has to stay underneath. Does everybody understand why those two look that way? This one resulted because the 9 was square rootable, so the 3 popped out. This came out because the x squared was square rootable, so the x came out. That's why they look different. Okay, your inners, that's just your negative 5 times the square root of 3. That's just negative 5 root 3. And then your last is just negative 5 root x. So you're just kind of like eyeballing your equal signs there. I actually only see 2 things that can combine. So I see a negative 5 root x here, and I see a 3 root x. Just something to keep in mind. I'll throw it in yellow. Caution. the x root 3 and the negative 5 root 3. Those can't combine because x and negative 5 aren't like. So all I can put together right now are the pieces in blue. So 3 root x and negative 5 root x, that's just negative 2 root x. You'd bring down your plus x root 3 and your minus 5 root 3. And then that's it. So the last step in FOIL is to do f plus o plus I plus l, but sometimes we can't combine all of the pieces. All right, if you understand these two, you're doing a great job. We are almost done. I wanted to emphasize a pattern we see again next week. Again, sometimes we can multiply things together and the radicals go away. So I am going to go ahead and take the square root of 2x times the square root of 2x. Again, I'm just foiling, apparently in blue now because I just left the stylus on that color. All right, so the square root of 2x times the square root of 2x will get this started. That's the square root of 4x squared. That's just 2x. Poof, radical gone. So exciting. Okay, your outers. What's that?
Instead of multiplying, couldn't you just move?
Yeah, because the square, it's like the square root of 2x squared. Yeah, totally. Nice job. And we got the square root of 2x times 4. And that's 4 root 2x. Inners is negative 4 root 2x, which is super fun. And then negative 4 times positive 4, that's just negative 16. So when you go to combine, do you see how you have positive 4 root 2x and negative 4 root 2x? Those guys go away. So all you have left is just 2x minus 16. No radical in that answer. So we took all these things that had square roots in it and we got something that didn't even have a square root in it anymore. That's actually really, really important for next week. The hint is in the signs, people. Talk about that. So far away though, right? Okay. Last problem for us all together as a group. It's a booby trap. We're trapped. Just don't distribute the squared in. It is so tempting to do because it does make the problem so much faster, but it also makes it wrong, which is not as advantageous. We would just write this out twice. There is definitely one of these on your quiz next week. Not next week, I'm sorry, the week after. So we're going to FOIL. Square root of 3x times the square root of 3x. I mean, Alex knows that is 3x, but if you need to show some work, we can. That's the square root of 9x squared. Square root of 9 is 3. Square root of x squared is x. Outers would be the square root of 3x times 2. That's just 2 root 3x. And then your inners is also 2 root 3x. And then your last would be 2 times 2. That's 4. And then the last step that we take care of is combining like terms. So in this case, the only things I see that I could put together are those two that I highlighted red there. Because 3x and 4, I mean, they don't have any friends. They're friendless. So I would write this as 3x, and then 2 root 3x and 2 root 3x, that's 4 root 3x plus 4. Bask in the glow of everything you've done today. You had a really busy day. So now you have a couple of independent practice problems. You can use those to wrap up your day if you would like. And then there's some answers to those independent practices. Again, these can be found in your archive if you need them.